Welcome learners for the lecture 21 of a differential geometry. Today we discuss about the last topic of this unit, that is a double family of a curve. What is double family of a curve? That will be gated. We have characterized a family of a curve by a differential geometry of the form, that is a P du plus Q dv equals to 0. So it is a natural to expert a quadratic equation, that is a du upon dv. In the du dv will give a double family of a curve, that will be say to the definition. If pq and r are the continuous function of a u and v, we do not vanish together, and if condition will be given, that is a q square minus pr is greater than 0, then the quadratic differential equation generated p du square plus 2q du dv plus r dv square equals to 0. This is the equation first. Two family of a curve in a given surface is given, that is a du dv gives the direction ratio of the tangential direction at a point on the surface. We obtain to the two directions of a double family and solving to the quadratic equation. Then P du upon dv square plus 2q du upon dv plus r equals to 0. Hence the questions naturally arises under what condition will be given to direction is the changes become a orthogonal direction. This answer is containing to the theorem, following theorem. Okay, theorem first, the two directions given by P du square plus 2q du dv means a divide divide all this part, that is a du square, then equation will be generated first. Are orthogonal on a surface if and only if er minus 2qf plus gp equals to 0. Then what is the proof? If lm and l dash m dash are the direction coefficients of the two family of a curve, equation first at a point surface, then L by M and L dash M dash are the root of a quadratic equation. Then equation will be given in a first equation. L by M plus L dash M dash equals to minus 2Q upon P, or L into L dash upon M into M dash equals to R by P. Then theorem consider to the M, that is the LM and L dash M dash are the orthogonal if and only if E consider to the value, that is the R by P, double L dash upon M dash plus F consider plus G equals to 0. Okay, in the first time solving to the condition, easily obtain to the value, that is put it to the equation and using to the equation er minus 2fq plus gp equals to 0. Then this will be given to the condition, that is the equation 4, and corollary will be show parametric curves are the orthogonal if and only the differential equation of a parametric curve is a du into dv equals to 0. Hence equation 6 is a double family with a p equals to 0 and q is not equals to 0 and r equals to 0. Only q is not equals to 0. This condition show in orthogonality become qf equals to 0. Hence q is not equals to 0, f equals to 0, which is the proof of the corollary. Then example will be given. Show that to the curve du square minus u square plus v square dv square equals to 0 from an orthogonal system on the rigid helicoids. Okay, equation first will be given du square minus u square plus c square dv square equals to 0. R equals to u cos v and u sin v, and cv will be considered. U consider both of this form, but v is generated as an angle will be considering. Equation first is a double family of a curve on the second with the p equals to 1, q equals to 0 and r equals to minus u square plus c square in this value. For the rigid helicoids, we given to the form r equals to cos v, sin v and 0, and r to consider minus u sin v, u cos v and c will be considered. Then you know that equation will be given E equals to r1 into r2 equals to 1, f equals to r1 into r2 equals to 0 and g equals to r2 into r2 u square plus c square, comparing to the form. Then put up to the value of their general equation er minus 2fq plus gp equals to 1 minus u, both of these conditions, so that the condition of orthogonality is satisfied in the all form of equation and to the form of a orthogonal system. This your second unit will be complete oh sorry, your first unit will be completing in all form. Okay, last topic will be considered.